Hi, and welcome to This Is My Architecture. Today I'm with Andreas from OnePlusX. Hi, Andreas.
Hi, Ross.
What can you tell us about OnePlusX?
OnePlusX is a Swiss company who has a software as a service product, which is a data management platform. And this is a software or product that media companies, publishers, and marketers can use to ingest, process, enrich, and activate their user data.
All right. And what part of OnePlusX are we going to be talking about today?
So we're actually going to talk about the core of the data management platform, where we go from event data to user profiles.
All right, I'm looking forward to it. Why don't you start taking us through what we see on the board here?
Yes, so we can try to follow an event through as it flows through the system. So it's a streaming-based system that has Kafka as a backbone. So when we start with an event where a user visits a website of our customers, say the user reads an article about the Olympics, then the event will come in here into our ingestion component, which runs on ECS. Here it will be cleaned, processed, and prepared for the internal processing. And it will go here to Kafka, and will also go to S3. Then in the next step, we go to the aggregation and machine learning step. So here we actually go from event level data, so data that says a user did something at a certain point in time, to attributes for users, so making statements about users. A simple attribute could be what is the total number of events that this user had in the past. But there are also more complicated attributes, and that's why there's the machine learning here, for example, to predict the gender of the user based on their past behavior. So this is happening in this step. After that, we have the data again in Kafka. So the outputs here are the user attributes. We go to the next step, the profile step. So again, here we have a connection. So here we basically combine all the user attribute data that we have computed in this previous step. Since we had in the previous step different components that were computing user attributes, here we combine them in the profile step. And we actually also have storage here, a Couchbase database, and also an Elasticsearch actually to represent that data. What we also do here is we compute so-called audiences. Audiences are groups of users that are customer defined. For example, the customer could define, I want everybody who is interested in the Olympics. And since our user that we are following through the system here has now shown that they're interested in the Olympics, this user would be part of that audience. This information goes back to Kafka and then goes into the serving part of the system, which is again an ECS service with a Couchbase database. And here the data, this audience membership data, is indexed such that it can be accessed when the customer queries that.
Okay, so that provides some level of separation between, we have real-time streaming essentially here coming through Kafka, and you're storing some sort of view of that data here. How does that sort of affect the design of the system? What happens if your real-time streaming goes down? What is the effect on how your users are able to continue using your system?
Yes, so in general, we want, of course, to be fault tolerant. We want to be highly available, but we're also dealing with massive volumes of data. So a typical customer would have multiple billions of events per month and tens of millions of profiles. And we want to do this whole thing cost effectively. So the solution that we came up with for this is that we have two different fault tolerance strategies for the periphery of the system, ingestion and serving part, and the core. So for the periphery, where we have the interfaces to the customer, we have distribution to multiple availability zones. We have auto-scaling, load balancers, everything. We have replication in the databases and so on. So we try to keep this working at all times. In the core, we actually embrace failure instead of trying to avoid failure. So we have this Kafka, we have these services, these databases only in one availability zone. Some of those databases are even not replicated. You would say, okay, how can you do that? So the thing is, we have mechanisms to recover the data whenever we have corrupt data anywhere that we can employ to, within minutes to hours, basically recreate any state here in any part of the system.
Okay.
Yes.
I want to go back to a number you dropped there when you were describing that, when you spoke about billions of events for a user. What effect does that have on scaling the infrastructure that we see?
Yes, so all the components that we use have to be inherently scalable. So we use ECS Fargate. We don't run our own clusters. We think it's great that we can just run services as containers, basically, and don't think of clusters. And then we can use auto-scaling also here to adjust to changing load. For example, at night, of course, we have less load, less traffic on websites than during the day. We have EMR here, which we use in combination with S3, actually. So we don't have an HDFS, we don't have one single EMR cluster, we have the data in S3, and we dynamically spawn EMR clusters based on the demand that we currently have. And we can run hundreds of nodes if we need to for a big job, or just 5 nodes for some small experiment.
Okay. And then one other thing, I mean, seeing you're a Swiss company, you have a lot of customers within Europe, GDPR always comes up in these discussions. How does that affect what you have?
Yes, that's a challenge. So under GDPR, users have the right to delete their data at any point. So when a user requests the deletion, we have to make sure that it's gone from all these databases there within a reasonable amount of time. So this kind of conflicts with a typical pattern around Kafka here, like this event sourcing pattern where you would typically keep your event data for very long, such that in case of a failure or some kind of need to restore a system state, you can go back, you can basically rewind and just replay everything. Now, if this data is user data and this user has requested the deletion of their data, you cannot do that. Like, that's problematic. In Kafka, you cannot really delete records by key. So what we came up with here is mainly in this component. So we actually, when we go from events to user level data, we use a combination of batch and stream processing. And we only keep a short history of events in Kafka that automatically expires, so the user deletion is granted. And we keep files for historical data in S3 where we run deletion jobs. And we compute the result of the whole component of the whole aggregation, maybe the event count that I mentioned before, or the gender probability, as a combination of results of a batch job running on EMR and the computation that runs on ECS on the newest events.
That is great to hear. It's always a challenge for customers to implement GDPR correctly. Andreas, I've got to say thank you for joining us today and sharing the architecture of OnePlus X.
Thanks for having me.
And thank you for watching This Is My Architecture.